Hey everyone! In this video we are going to be solving a one-dimensional momentum recoil problem. We're actually going to be doing two examples, one where we solve for velocity and one for mass. Let's get started. The first thing we're going to do is highlight key pieces of information. The captain is 70 kilograms and they stand upon a canoe that is 100 kilograms. And we can see that the canoe was going 2 meters per second forward when the captain suddenly jumps off the front at 6 meters per second. So because the captain jumps off the front, it's going to be the same direction that the canoe was going. These are both going to be positive. What is the new velocity of the canoe? So let's go ahead and get our momentum equation up here. For recoil, our equation is m1 plus m2 v. In a recoil problem, both objects count as a single object in the beginning. It's the exact opposite of inelastic, where they combine and fuse together to become one. They start off as one object, and then they separate to become two unique objects, each with their own new velocity. Let's go ahead and fill the information in that we have. Mass 1, that's the captain, is 70 kilograms. Our mass 2, that's the canoe, is 100 kilograms. And in the beginning, because the captain's on the canoe and they're moving together, they have the same velocity, which is 2 meters per second forward. However, after the captain jumps off, things are going to be a little different, because now that 70 kilogram captain has leaped off the front at 6 meters per second, and something is going to happen to our canoe. The canoe, 100 kilograms, V2 prime. Prime means after some event. In this case, captain leaping off. Let's multiply this out and see what we get. 70 plus 100 multiplied by 2, that's 340. This is going to equal 420 plus 100 V2 prime, the velocity of the canoe that we're solving for. We subtract 420 from both sides, and it leaves us with negative 80 equals 100 V2 prime. Divide both sides by 100. So if you get this far, it's just rearranging equations, and you get a final answer of V2 equals negative 0.8 meters per second. This makes sense. The captain leaps off the front of a boat, the boat lurches backwards. If anyone's ever jumped off a boat before, you've got to be careful, because when you step off one way, the boat goes the other. Let's take a look at another example where we're solving for mass. So this is also a one-dimensional momentum recoil problem. That means two objects starting together and then separating, only this time we have an unknown mass. Let's highlight the key information. A crew of pirates have loaded their stationary, if you remember, stationary means not moving, 200 kilogram cannon with a homemade cannonball of unknown mass. So they made their own cannonball, but they don't know how heavy it is. On firing, the cannonball flies out at 250 meters per second. The cannon recoils backwards at 2 meters per second. Solve the mass of the homemade cannonball. We have all of the information that we need. Let's go ahead and get this into our equation. The equation for recoil, just the one we just used, is m1 plus m2v. Remember, in a recoil question, both of the objects start as one big combined object. Then they separate after some event, in this case, a cannonball being fired, and becomes m1v1 prime plus m2v2 prime. We'll go ahead and fill it in. Mass 1 can be our cannon. So our cannon is 200 kilograms plus m2, which we do not know. That's going to be the mass of our cannon. V is the combined velocity in the beginning. However, we know what that is because it's stationary, so that initial velocity is just going to be 0. We can fill in the mass 1 of our cannon again. That's 200. It stays the same after the fact, But that V1 prime is the cannon recoiling backwards. It's lurching backwards, so it's going to be a negative 2 meters per second. Do not stand behind the cannon when firing. Plus M2, the cannonball is still unknown, but we do know the velocity of the cannonball after it's fired. It's 250 meters per second. And we can go ahead and clean this up. Because all of this in the beginning is multiplied by 0, that's going to equal 0. Negative 400 plus 250 M2. Watch out for those stationary questions. Often my students have tricky times because they try and fill in numbers and they end up with a big mess. When you get those stationary objects, you smile to yourself because that's a nice big 0. And it's going to make this question much easier. We add 400 to both sides, and we end up with 400 equals 250 M2 divided by 250 divided by 250, and you get the mass of the cannonball is equal to 1.6 kilograms. If you somehow got a negative number, you would know that you filled something in incorrectly because we cannot have negative masses. I hope that this was helpful for you. Good luck solving all of your momentum problems, and if you have any questions, please feel free to leave them in the comments down below. Have a great time with this.